everyone. Good afternoon, good evening, wherever time zone you are joining in. My name is Victor Monga. This webinar is presented for CSALA SoCal chapter. We have it on the screen QR code. If you would like to stay in touch with us, this QR code will take you to CSALA LinkedIn, CSALA Twitter, YouTube channel, our meetup site where you can stay up to date for our events. So CSALA has partnered with the community called Virtually Testing. It's a nonprofit 501c3 community, which is sole purpose is to provide online free education to other groups and communities. So today we have invited Mr. Moses to present for our webinar. And again, the title is Cloud Penetration Testing. So during all of this is going on, even prior to that, we had a lot of hype about what's going on in cloud, how to be secure, how to test it. So today we'll cover some of those topics. Basic frequently asked questions. How do I get my slide deck? This will be posted on our Git and also LinkedIn. All the questions that you would like to ask us, please post it in Q&A section so we can answer them and everybody can see them. It is recording, so it will be posted on our YouTube channel as well. For more events, we will provide you QR code and also you can check it on our social media. All right, with that, Moses, all yours.
Hopefully everybody's mentally okay, physically okay, and staying safe. So a little bit about myself. I'm Moses Frost. I've been working for Cisco since 2012. I've been in the IT industry for about almost 20 years now. Don't actually, probably a little bit more, since the late 90s. I am a course author for SAND as well as an instructor. Been doing that since 2008, 2009. I author 642, which is the advanced web app pen testing course, and this new one, 588, which is a cloud penetration testing course. And today we're going to be talking about cloud penetration testing as the differences, I guess, between them. And I'll show you some demos, and I'll leave it open for Q&A and make sure that, actually, let me make sure the Q&A panel is on the right. So if there's any questions, I'll try to pause every so often. So I'll try to pause every 10 to 20 minutes or so to answer any questions. There's a lot of topics in here. There's a lot to cover. So what I'll do is I'll give you a base kind of foundational knowledge of some of the topics, and then we'll do some demos and you can ask questions along the way. So let's kick it off. All right, so just my disclaimer, so that, hey bro, don't sue me kind of disclaimer, hands up. You never know, right? These are my opinions. It's my brain, it's my thoughts. You can go after me, I guess. Don't do that. But we try to be even-handed here, right? So, all right. So, by the way, so this is also not a knock on anybody's cloud services. So, for example, if you see that I have a lot of AWS examples, this is not to say that AWS is better or worse, right? If you see any GCP examples, this is not to say that Google Cloud is better or worse, right? Or Azure, or any one of those, right? This is general cloud stuff that impacts the community as a whole, right? So whether you're running a private cloud, a function as a service in your environment, an Azure stack locally, whatever, right? These are things that you need to be made aware of, right? This is definitely not to start a philosophical, religious debate or whatever, right? I do. If you ask me, do I use any one of these cloud providers? The answer is yes, right? So just because I talk about it the way that I talk about it, or that I show you something that you could do instead of these cloud environments, doesn't mean that I stick my head in the sand and go, oh, oh, you can't use them and they're terrible and whatever, right? Because that's not the case. But there are some things you have to think through, right? So this is all about approach. This is all about methodology. This is all about what things are, right? How they are. All right, so let's talk a little bit about penetration testing as a discipline for those that have never, 101 stuff, for those that have never thought about it, right? And so to me, when I look at a penetration testing um, kind of workflow, right? The idea and the reason that I kind of gravitate towards it is because I like, just like many developers that have ever done test driven development, right? I like to make sure that things work the way they're supposed to work as we put them together. So designing something and building something is great, but if you don't test it, if you don't make sure that the bridge you're walking on can withstand 100 pounds of weight, 200 pounds of weight, or a ton of weight, right? Then it's not a very good bridge, right? It's a wooden bridge that you'll fall through, right? Um, so, right, classic example, I have antivirus. That's great. What does it catch? Well, it catches, these types of threats. Okay, well, that's good to know, right? It's good to know that the antivirus software that you are using does an effective job against this, but not that. Okay, great. I have a firewall. Fantastic. And I have all these firewall rules. That's great. But at the top of my firewall, I have a rule that allows everything. Well, that's bad, right? And unless you've actually tested the fact that ports are allowed through that firewall, you're not going to know that, right? And how you do the testing, well, we'll talk about that, but that's the idea, right? Now, I have, this is my favorite one, right? I have a strong password policy because to my eye, it's very complex, right? It's got all these digits and all these numbers and upper cases and lower cases and whatever. How do you know it's complex, right? How have you tested that? Oh, well, I found this password in a password site that every attacker knows. Well, that's not really a secure password, is it? That's more like an insecure password that is because it's everywhere. It's a known secret, right? It's the winter, it's the season and the year. Well, okay, that's great. So, how do you know that you have a strong secure password policy? And so, this is the kind of stuff that a pen test can ferret out, right? And when we talk about pen tests, traditionally, we're talking about looking at taking things, whether they're firewall security models, whether it's binaries that you've built, and putting it through a testing framework or a methodology to ferret out whether your organization is at risk or not. Right? That's a pretty generic way of looking at it. Now, when you look at how most penetration tests have classically been done, right? Now, I'm not talking about what the people have been doing the last few years. I'm just saying about classic pen tests. When you look at it, you say, okay, I've got a data center. It's hosted on premise or it's hosted in the cloud, and these data center servers have things, right? They've got services. They're running file shares. They're running Active Directory. They're Windows clients that are hooked up to Active Directory. They've got, I've got different devices and MDMs and all the traditional enterprise stuff that's out there. And I want to test that. That's great. You want to look for that stuff. You want to find out if things like responder work, right? If you can actually get clients to navigate to you as an attacker, and then whether they can give you their credentials. All that is great. And I do not preclude you from trying that out. Okay. I totally think you should. But that's not what we're trying to do in a cloud penetration test per se, right? I'm not saying you can't do this as part of the pen test, right? Because you totally can attack these services. But when we start looking at cloud services, we start having to take a different view of what our traditional penetration testing thoughts are, right? What we're trying to accomplish, right? And so, one of the things about cloud is that they're typically, not always, right, but they're typically highly dynamic environments that are designed to scale. And instead of having servers that provide services, many times the services are provided by the cloud infrastructure provider themselves. And it's done that way for scalability. It's done that way because compute may or may not be always available. It is a different workflow. And yes, connectivity can be delivered over the cloud as a public IP address, but it could also be privatized and not necessarily made public, right? And so the way that we're looking at testing, right, might be instead of saying Active Directory clients talking to an Active Directory server, it could be something as like the service is in a container, the container lives in Kubernetes, and that Kubernetes cloud is attached to Amazon or Google Kubernetes engine, right? And so now, if I want to access this server, if I want to attack these things, right, I now have to think through how authentication and identity controls are done inside of a Kubernetes environment and in an Amazon or Google Cloud versus how they were done in traditional Windows environments. Okay, so now I'm not going to be looking at, well, I want these hashes, and then these hashes allow me to fully pivot. I might be thinking about, well, I want these keys or these tokens, and these tokens will let me pivot, right? Same kind of concept, different animal, right? More or less. And so this is kind of the view of the world, right? It's a little bit different skill set, it's a little bit different tooling, but at the same token, it is something that we naturally start to want to work through, right? It's kind of so one of these things that we'll look at and see how it impacts us. Now, when I normally talk about cloud, and and I'll start talking about public utility clouds. Not that I'm excluding private clouds, because private clouds can, and I hate to use the word suffer, but suffer from the same issues, right? There's nothing technically unique about public or private clouds. They just are either heterogeneous or not, right? So, as an example, when you're in your data center and you want to build compute, and whether that compute is physical or virtual machines, right? Because you can have bare metal compute or virtual compute. You typically will be dealing with a physical piece of gear or virtual, and you will have an out of band management construct of sorts, right? Now, that could be physical keyboard access where you say, hey, I got a keyboard and mouse. Could do that. Or you've got a out of band manager like a IPMI interface, a Dell DRAC, an HP ILO, Cisco UCS Manager. What's another one? A VMware hypervisor, right? The VMware hypervisor, the KVM hypervisor layer, the Zen server hypervisor layer, right? These are all the way that you access the physical or virtual hardware gear. And in that case, you start to actually type things through, right? Well, do you have that in the cloud? And yes, right? The answer is yes. In the cloud, you have the Amazon, Google, Azure console, right? And I want to exclude Google, or Alibaba, Oracle Cloud, right? These are all consoles. So you have these, and at the same time, these services are also exposed programmatically through a CLI. And this enables you to build highly dynamic interfaces so that you can actually design tooling around it, right? So you can actually build an entire infrastructure through that CLI environment. Okay. And because you're trying to program it and because you want to automate it, this gives an opportunity for an attacker to now gain access to that same console through the use of these keys, right? And there are ways to protect the keys. There are ways to rotate the keys, but many individuals that are out there do not realize that this is a security issue, and not realizing that it's a security issue, they've not protected their keys. Okay, and as we've built these, let's face it, we build these systems, we find out what's the problem with building them the way we build them, and we come up with these anti-patterns, right? There's basically bad things to do, and those anti-patterns give attackers the opportunity to actually go out and attack these environments, right? So anyway, so we'll talk about some of these things here in a minute. Now, as you move from cloud into what we know as cloud native, right? So let's abstract it one more section. When we move into cloud native environments where we're building cloud native applications, or however you want to design it, right? We'll just take the CNCF definition of cloud native. You're typically containerizing your software package and you're managing it in a container managed environment. And there's a few container managed environments out there. There's some that are cloud specific. So Amazon Elastic Container Service is a cloud specific service for Amazon, right? Kubernetes is a cross platform way to do it. And so you could have Kubernetes on premise. You could have Kubernetes in your data center. You could have Kubernetes in a cloud environment. You could have Kubernetes span both cloud environments, right? So you could have a Kubernetes node in cloud environment one, and I guess you could have Kubernetes node in cloud environment two, or you could have multiple Kubernetes stacks, right? It's really however you want to design it.
Hey, Moses.
And then,
Hey,
yeah.
sorry to interrupt you. We have a question. Mary, go ahead if you want to ask your question, please. Mary, do you want to type your question or would you like to ask verbally? No? Okay. Sorry about that. Continue.
No, it's
Moses.
fine. Yeah, it's fine. And I don't know, was that through a hand or?
Yeah, that was through a hand. I saw a hand raised. So.
Oh yeah. Okay. Yeah. I guess that's a good point, right? So if you want to ask a question, you raise your hand. Yeah. All right. Yeah. So these are kind of the ways that we talk about it. Yeah. Yeah. So this is kind of the way that we discuss it, right? So we discuss container environments, ECS, Kubernetes, Docker Swarm, right? And all of these environments that are cloud native, managed to a container, that kind of thing. So you might hear me say cloud native environments. That's what we're talking about. Now, there's also this concept of having services, right? And so some of the services that are pretty typical in an environment are things like files, right? And file shares were one of the first services delivered in the cloud, right? And so it seems obvious most people want to share documents. So typical file sharing technologies that we've been using classically that have caused us some issues, right? SMB, right? SMB has been a very attacked protocol, right? NFS, right? NFS, classic protocol for Unix. FTP, FTP, another classic problem. The other day, I stood up an FTP honeypot on the internet, and I left it alone for like months. And they broke out of the jail. They totally used it as a node, right? All this stuff that they were doing with just a classic FTP server, right? It's pretty interesting to see that, right? But these protocols that were designed for the 90s, 80s LAN, WAN localized environment don't necessarily translate as well over the internet. So what you saw over the last, say, 10, 15 years, or 10 or so years in file shares is now we have a couple of different technologies being used. Number one, we've got this idea of a block object storage where the file can live inside of S3 or Azure files or some technology like this, but the file is distributed across multiple physical nodes, and those multiple physical nodes allow for resiliency of that file. Okay, cool. You also have the idea that a that file object store is available over a RESTful call. So HTTP instead of SMB, right? Because HTTP is kind of universal. Well, most of these technologies, like the public cloud technologies, they'll have their SDK, they'll have their CLI, and then they'll have the ability for you to use those tools to copy files, right? And so that makes it kind of interesting. Also, cloud native environments can take advantage of these S3 buckets or these Azure files or Google files, and they can store and recall files out of those S3 buckets as part of their application stack if they have enough permissions. And that's a whole other thing we'll talk about, permissions being a huge thing here. And then, of course, you have this concept of like identity and permissions in the cloud, right? And this is where it gets extremely interesting. So, um, Microsoft Active Directory or an LDAP server has been the primary identity source for many classic enterprises, right? This is what we have used and have learned, right? And these protocols that built LDAP and Active Directory and everything else, um, they have been battle tested and the like. And we all know, or if you don't know, there's much research about how these protocols can be not as secure as we like them to be, or the security boundary for Active Directory and LDAP servers and the like are maybe too wide, right? Whatever. So in the cloud, there is not a duplication of this per se. Now there are some interesting ways that we could talk about this, right? So, for example, uh, Microsoft does support SMB in Azure files, and they do support Active Directory in Azure files. So if you want your Windows operating system in Azure to talk to Azure files, you can use SMB and you can use Active Directory, and all the issues that have extended to the classic enterprise extend to the cloud, and that's it, right? But more interestingly, Azure has created their, or they've modified their Active Directory federated services component, and they've built this thing called Azure AD. And Azure AD, Azure Active Directory, is not classic Active Directory that you know. And actually, the classic Active Directory service that you know in your environment is called Azure Active Directory Domain Services. It's a different thing. Azure AD is SAML, it's federated OAuth and the like. And Azure AD permissioning is what is used for the Azure AD services. So it's both a federated service environment for federated services like Office 365 and the like, and it controls your local Azure permissions between services. So it does both. Well, Amazon sort of kind of has the same thing in that they have Amazon AWS IAM. And the reason that we talk about IAM is if you want your Amazon Elastic Compute the computer, their virtual machine, to execute or trigger a Lambda function, to access an S3 bucket, to do one of those things, it has to have, when it boots, the right permission attached to the machine. And that AWS IAM permission um, will be used in attacks, and we'll show you how that kind of works and how those systems work. But it's important to just, for now, understand that if I have a Amazon computer and I wanted to talk to an S3 bucket, and that S3 bucket is not public or not, anonymously available, then I have to give it the permissions to talk to that bucket. If I wanted to execute a Lambda function, I have to give it permissions to access that Lambda function. Now, Kubernetes originally didn't have this, right? It didn't have RBAC. It now does. So a Kubernetes node actually has certificates and permissions to talk to a Kubernetes master. All right, well, that's interesting. What's what's more interesting is if I get a container on that node, and that container can read things like the AWS IAM permissions, then you can also start to execute certain things potentially on the nodes. And so how you do permissions in these cloud environments is critical, because there are some um, legacy or some like architectural things about the cloud that are going to be really difficult for those cloud environments to change, given how widely used they are and how cemented in the organization they are. So anyway, this is just some concepts, one-on-one stuff that I just want to kind of walk through. All right, so how do I test? What do I test? Right, what I got testing. What I test. So here's an environment. I just took this picture from Amazon architecture stuff, and it's like, hey, how do you architect a microservice, right? And so the idea here is you've got these services, right? And they've divided it into like these sections, right? So I'm just gonna kind of highlight this, right? So on the left, you have Amazon CloudFront and S3 buckets. Maybe your server or your user um, hits the Amazon CloudFront service, which means it basically can, geographically load balance, and it has some CDN caching. That service might reach out to S3 buckets for that or whatever. It hits the load balancer. The load balancer gets it to your container. And your container is like this immutable application that's not supposed to change. And then that container has to use its rights to talk to a database. Maybe that right to talk to a database is based on just regular classic TCP/IP ports. That's kind of not special, but whatever, right? Let's say it's that. But let's say that in order for it to read the database stuff, it needs access to certificates or keys, right? It might have access to talk to Elasticache over a TCP/IP port, but it also might have access to execute a microservice call or a call to the AWS IAM to natively talk to it, right? It may need to be able to do native calls. And so every time your container wants to do a function, or every time your container wants to do a thing, it needs to talk to this IAM tier to say, do I have access, right? And so in Azure AD, this is a big deal. In Google Cloud IAM, this is a big deal. And Kubernetes is a big deal, right? Because there's always this constant permissioning that has to happen to say, am I allowed to do this, right? As an attacker, this is two things, right? This is number one, the opportunity for us to try to figure out how that key management works and can we use those keys for ourselves. And number two, it's a roadblock, right? Or it's not a roadblock. It's not like you can't do something. It's more like a trampoline, right? You got to figure out how I can jump over and figure out how I can actually get to that next level, right? That's the idea. So with that said, the key material, what is this? What are the keys, right? So the way that I break this out is kind of generic, okay? But it's good to think about your keys and how you do key material. So the first type of keys that you have is username and password. Classic username and password. So I'm in Azure. I'm in the Azure CLI. I can actually log in if I have permission as an administrator. I can log in and say Azure login username password, right? And that's recorded in my shell history, right? So you can already see the problem there, right? Very weak. Now, you could do that in the portal. You could do it in the CLI. There's also Azure launching an actual web browser. And when Azure launches a web browser, it can say, well, username, password, and you have to have MFA, right? Multi-factor. If you have a multi-factor authentication with a phone, this is one step better. But we do know, by the way, that multi-factor authentication with a phone is not as secure as a physical MFA, right? So if you can do a physical multi-factor authentication token, this is better, right? And so, you could pick up some YubiKeys for $40 and you could physically set this up, right? And so that's just good, better, best, right? Great. Now, what about, by the way, even if you use Google Authenticator on your cell phone or, one of those systems, that's better than the phone call. And for those people that are like, well, phone call, etc., look up SIM swapping, right? Where, living in Florida, I got to at least hear about this first. Not in my city, but in another city in Florida, there was actually a couple of people that got arrested working at a cell phone store at the mall one of those cell phone kiosks, because they were getting paid to take phone numbers of people that were known to have large amounts of Bitcoin or some kind of cryptocurrency. And they were taking those phone numbers and porting the phone numbers from one cell phone provider to the attacker's cell phone provider, right? So think about your phone number now leaving your possession and going somewhere else. And then they were doing the password reset on the phone numbers, right? It's called a SIM swap. And this is just, I mean, Reddit got hit with this. A bunch of people got hit with this. So just so you know, this is like an attack, right? So that's why we say not as secure. There's also programmatic access with API keys. We're going to be talking about those today. And there's programmatic access with API keys that have expiring session tokens. Now, this is something that Amazon does with their IAM service. There's programmatic access with API keys and MFA. So this is, I want to give my administrators, right? So I want to give my developers a way for them to get an API key, right? Because in Amazon, you have an API key. And with that API key, you have a token, right? So think of it as a username and password. And as part of that API key and token, you must provide the 6-digit um, OTP, right, from the 6-digit string that's in your Google Authenticator or whatever you use as part of that access. And the way that Amazon does it is they actually use a library called the Amazon AWS STS service, which actually allows for this. And so if you've never seen that, I do have an example of that, and I can show you that here in a second. I probably should have brought that up, but there is an Amazon AWS STS with MFA. Yeah, here you go. And so for those that have never seen this, this is how you would do it. You would actually type this in, and I'll leave this up for a second, but it's the Amazon STS. You get a session token, you give it the serial number of the MFA device that you're using, and you get a token code from the token. And that's how Amazon provides you with a temporary key. This is for technically for a human, right? Could you do this programmatically? I think you can do it programmatically. There's actually I've seen it done with things like Authy and the like, but probably defeats the idea of doing this way. But you can do it. They have a whole write up on how to do it, etc. So just FYI on that. Just FYI. Not every cloud provider will support this, by the way. Microsoft uses OAuth, right? So OAuth is another, kind of, you have to have an OAuth credential, and then that OAuth credential gives you a temporary token for your session. Another programmatic way of doing it. And then generically, SSH and certificates to access the actual systems, right? And so how you do this, what keys you trust, how you do your trust, how you safeguard those SSH keys. I put my SSH keys on a YubiKey, right? And people are like, you could do that? And I'm like, yeah, you could take PGP, which you could put on a YubiKey, and you could use your PGP keys to sign your GitHub, to log into SSH, things like that. So just saying, you could do this as another option. Now, there are ways that we can do this, right? As an attacker, and let me actually get rid of this. Sorry, Brave. I don't want to roam around in my Brave socks right now. Yeah, sorry about that. That's, supporting the cause, right? Anyway, so there are ways that you could do programmatic access. And what I like to talk about as a first pass, right, as not the only way, right, but as a very logical way of approaching this, is there is username and password access for management consoles, for CLI tools, and there's programmatic access and certificates. And so I like to first use system administration tools that a system administrator would use to actually do the attack stuff. as a first pass, right? Because it looks normal, right? Now, not everything can be done with a system administration tool, and not everything is easy, and it's not point and click, and it's not, all the other fancy stuff, right? But if I've got keys, or if I've got passwords, or if I've got key material, I don't have to run exploits, right? I can just use that to log in. And it will be a little harder for the folks that are doing the detection to detect that, right? Now, the whole point of this is to make the detecting people detect better, right? So you want to make sure that the people that are doing the detection can effectively do the detection, okay? Now, um, this is the way that I look at attacking a cloud service. I look at attacking the cloud controlling layer, right? The cloud admin layer. I look at attacking the standard access layer, and then I look at attacking the service layer, right? And of course, I want to either gain access through credentials, whether that's on the virtual machine or in the cloud controlling layer. And if I'm in your cloud control layer, I basically have God rights to your machines, period. Or I might want to look for classic software bugs that will give me access to the cloud controlling layer. Or I might want to escalate through incorrect permissions, right? So this is how you would go through and attack a cloudish application at a high level, right? Through the different parameters, right? Well, I'm actually going to show you this here in a second. But this is, by the way to look at your full attack surface, right? This is your attack surface, and it's kind of like onions, right? It's kind of like concentric circles, right? You got to peel back the onion and you still get access. Um, all right, so the first thing we're going to talk about here is this idea of an instance metadata. So Google and Amazon, they both do this, right? When the cloud controlling layer of these systems want to look at services, the services actually have information about themselves that is available through a network socket. Okay. So think of the systems managers, the agents that could be running on this machine as having the capability to know about itself. Okay. And to know about yourself, you have to know what my unique instance number is, my security group, my firewall set, my unique network environment. All the things that make me unique, right, are in here. And so this API is called the Instance Metadata API. It is the same IP address on all the instances, and it basically tells you about the service or system that you're looking at. So the idea is, if you can access this instance metadata API through either a software bug or some other mechanism, it will spit things about it at you. Now, for many years, and Amazon changes this, and Google's been changing this as well. For many years, the security credentials, or think of it as your username and password, right, have been made available via clear text programmatically on purpose in this instance API to be able to facilitate programmatic access to access other services. Okay, so the idea here is you query, right, the cloud controlling layer. You say, what is my key? And it says, okay, here's your temporary key for the next hour to 6 hours, whatever. And using that key, you can now execute a function. You can actually execute a command, right? And so, as part of this is the way it's supposed to work. You can actually use your keys to access these different functions. Here's the thing though, if you as an attacker can read this information, you don't have to be inside of the environment to use it. And so if this compute virtual machine has the ability to query the key, and you can read those keys, and you put those keys into your command line interface, you can now access those Lambda functions from outside the environment. You can now access this S3 bucket from outside the environment. You do not have to have access to that instance metadata to do it. Okay, or I mean to the actual host machine to do it. Okay, so let's talk about this, right? Because I see a question here. Can you list out some tools that are being used to pen test the cloud? And the truth is, most of the tools that are being used to pen test the cloud, what they do is they take the command line interfaces, right? And I'll show you one now in a minute. They just take the command line interfaces that you have and they templatize it, right? And leveraging those templates, they automate this work. So the command line tools or the attack tools for the cloud automate what you're about to see. Right now, that's what they do. Okay, so so here's an example. So if an attacker can read the EC2 Lambda function or run an EC2 instance, and so another attack here would be, I have access to execute an EC2 instance, and in that EC2 instance, I can attach a role, and there's many reasons for this, but I can attach a role, and using that role, I can actually read the keys. So think about this. I run a VM. The VM has my SSH key. Having my SSH key, I can log into that VM. Logging into that VM, I can just run curl and attach to the EC2 metadata function, right? And then I can read the EC2 information, right? And I go from running a VM to reading a bucket, right? So it's like privilege escalation and things like this. So I'll show you a demo of this, right? So I recorded this demo. It is a live fire demo. So first of all, I will shout out to two people here. So two tools on this. So first of all, the first tool I'll talk about, I'll give you links. So Rhino Security does a great job with a couple of tools out there. They have a GitHub repo. You should check out some of the things on their GitHub. They have one tool called PackU. PackU is an automation tool. I'll put this in the chat so that people can see this on the chat. So PackU is basically a AWS automation tool for doing a lot of these attacks. So if you want to automate this stuff and you don't want to go through all the trouble of doing it by hand, PackU is great. They also have a dojo called CloudGoat, and I'm going to show you a CloudGoat demo here that they've built, because then you could go and do this yourself, right? And it's a very simple CloudGoat demo. It just requires you having an AWS account. That's it. So I'll put those two links there. You can have them, you can use them, etc. Highly recommend you go through these labs to understand Amazon, and honestly, by the nature of understanding Amazon, you'll start to think through how you could do Google, and you could think through how to do Azure. They each are kind of unique, right? They each have their own differences, right? They're not. It's like Unix and Linux, and Windows and mainframe, right? They're not. They're the same, but not, right? So, kind of have to think through how those attacks work.
Hey, Moses.
So here, I've recorded one for you.
Hey, this is Victor. Sorry.
Yeah.
We have a question. Doug is asking, what about permissions? So.
Permissions. Does one need AWS permissions? Oh, well, so okay. So let me explain a couple. So let me work through this attack, and I'm going to show you how some of the permissioning stuff works, because that's like in the cloud penetration testing course, we spend 2 or 3 days on permissions. Permissions are strange. We'll talk about that in a minute, but I'll show you how this works, and then we'll talk about permissions in a minute. So in this demo, and I'm just playing this tutorial demo here for a minute, I'm basically using the Amazon AWS command line interface to configure a profile for a user. And the user is said to have keys. However you get the original AWS keys, we could talk about. There's tons of ways that have happened in the past. But for now, we're just going to give you the starting point that you have a set of keys, okay? And you're going to see different ways to get keys throughout this demo. So I got keys. I put the keys in. It's kind of like, you don't see my screen?
I can see your screen. The cloud code,
Yeah.
CLI.
Yeah. Okay, good. Yeah. So here is me listing out Lambda functions in in AWS using the command line interface. Now these Lambda functions, when you list them out through the AWS CLI, they basically just say, you know, what the Lambda function is, where it exists, etc. The Lambda function at the top, the one up here at the top, the first one, has an environment variable with a set of Amazon keys. Now this is an older trick that developers used to use. It still happens today, where instead of using the appropriate ways to figure out API keys or using like bolts or something actually useful, they store the environment variables, or they store the keys in environment variables, which means you can read them. And so if you can read them, you can use those keys. And so you use those keys, and those keys, let's say they eventually tell you that they can do things like EC2. So in here, I use those keys to just read the compute function layer. And by reading the compute function layer, at a minimum, I get the IP address of this computer instance. So with the IP address of this computer instance, you could try to start to do vulnerability analysis of the machine. And so it's an Ubuntu server. It's running a web server. I'm just going to tell you a little bit about it here. The web server is running Node.js. It's just running a JavaScript Node.js server. And the JavaScript Node.js server has some functions. And basically, the idea is it has an attack known as a server-side request forgery attack, where you can manipulate the URL that the Node.js server points to. Some people believe that this is how the Capital One breach happened. And so the Capital One breach, they believe that you could modify the URL. And modifying the URL, they believe that you could actually read the instance metadata function. So in here, I'm reading through the instance metadata function, and the instance metadata function basically says that you have a set of things like the AMI and the ID and everything. And I'm going to start reading the IAM credentials. To know what the IAM credentials are, I have to go into the IAM subdirectory, and I have to ask for the role that is being used. And this role here, when you read into it, let's see, I probably typed it in wrong, but the role is dynamically generated. You don't know what the role name is, but since you could read the security credentials, you could read the role name. The role name actually was on the screen somewhere. Yeah, gotta put in right. I think it's 0. Yep. So here you could see that as I've requested a new credential, I get an API key, I get an access token, and I get a session token. And that session token is a dynamically generated session token that must be refreshed. Now, the new version of the Amazon IAM requires you to do this with 2 commands. It requires you to do a put request, and it requires you, on top of that put request, to do a get. So the idea is that a simple SSRF by itself would not be able to give you this, right? Now you have to migrate to IAM version 2, to the IAM metadata service version 2, which many people haven't. So just be aware that this, it was released in November, so it's about 6 months ago, and many people just haven't migrated their systems to this. So this attack is totally possible. Now, to use your metadata service, you got to go in and you got to do this, right? So you've got to actually go in, you got to put in the secret keys, you got to put in all of the access secret keys, you got to do all this stuff. And then you could go in and do this, right? And so you gotta go in and you gotta basically rebuild everything. And at this point, you gotta be able to do this part. So go in, and now using these new tokens, I can specify the profiles. I can specify the keys that I want to use, and I now go from Lambda function to EC2 function to now having probably screwed up. Go from basically just being able to list Lambda to being able to list Lambda and EC2 with a different set of keys to being able to now read S3 buckets, right? Now you've got to, I'm skipping the discovery part, right? You got to go out and figure out what permissions I have. Many people are like, well, how do you know what permissions you have? Many times you just got to try it. So you try this, you try that, you try this function. That's why you use the automated tools that try literally every single function. It gets very noisy. It's going to leave a lot of logs if you have logging enabled, but it works, right? So here, I'm going to use that role to record buckets, to list buckets. Come on. It's terribly, done, but let's see. So here, I listed out a bucket, and the bucket saved the admin user text file to my machine. So imagine somebody put keys in an S3 bucket for whatever reason, right? So now you could grab those keys, right, and take them. Now, from here, you might be able to grab another set of keys and execute another function or do more stuff, right? So maybe in the first permission, I could list out Lambda functions, but I couldn't execute those functions. So now I have execution rights. And with execution rights, I might be able to trigger a function that might be able to give me more data, right? So it's basically leveling you up from one permission set to another, to another, to another, walking you through how to get a key, how to get another key, how to get another key, how to get another key. Now Mary in the chat was asking, how can I protect my keys? How can I use an HSM, etc.? There are ways to protect these things, right? So Amazon has something called a KMS or a key management service. Azure has a key vault. HashiCorp has got their vault service, right? So there's all these ways to rotate your keys, to automate key storage, etc. But just remember, if you have your keys exposed and those keys can call KMS or the key vault, you can have the service decrypt on your behalf, right? So we do this in one of our labs in the class, right, where we have keys and we've got secret data, and the secret data is encrypted, and it's encrypted at rest, right? And we try to decrypt the secret data or read it, and you can't because it's encrypted. But if you're given enough access, you can actually go and ask for the system to do the decryption on your behalf, right? So you have to think through what keys are being used and what they could do. Now, Amazon, Google, Azure, most of these systems have done a decent job in trying to contain permissions. So, for example, AWS has got something called they have something called permission boundaries. And with service control policies and permission boundaries, you can restrict the maximum level of access that any one thing can do. Great, fantastic, beautiful, right? But there could be also a chance where you don't have permission boundaries, right? And so you got to kind of think through how those permission boundaries work, where they work, how you do rotations, how do you rotate those keys, where the boundaries are giving the maximum permission, allow you to do something, and what those things can do. Can you escape the boundary? So that there are thought processes that have to work. Like, for example, root keys. Amazon still has root keys available. if somebody has been logging in with their root username and password and not MFA and has created a set of root API keys, those root API keys do not respect IAM. They can do anything you want, right? So you can see how you've got to really be careful with how you've rolled out permissions, because it is both really can be really well done, and it's also really difficult to kind of understand. Um, so just be aware of that. See one. So that's Amazon. I'll pause for questions here because I'm going to switch gears to another attack. Is there any questions? Uh, what tools identify document permissions in AWS? So AWS came out with a tool set. The tool set was basically a tool set that allowed you to it basically allowed you to uh, figure out the effective permissions of any one given user, and it's called the AWS Access Advisor. So you go into the AWS IAM area, you go into Access Advisor, and you put in a role or a name, and it tells you the effective permission of that role or name. Cool. Yep. All right, now let's talk about Azure. Oh, Azure. So Azure is another interesting beast. There's so many weird things in Azure. So anyway, so um, I don't know if I'll be able to do this live for you because it might take us more than an hour, like 30. It all depends on how fast Azure's going today, because with everybody working from home, all the cloud providers are just slammed. So we could check. But anybody here in there, there's people in their organizations that have backup restore permissions. It's called DR, right? So if you have backup restore permissions, what can you do? Right? What's the worst that could happen? So I want to give you a scenario that we work through in an Azure environment. And by the way, this is not just Azure specific. This is could be for anyone. But here's something that you could think of doing if you have enough rights. So Azure gives you the ability to snapshot a disk. And so you could go in and, say, take a domain controller, which would be the most evil thing in the world that you could snapshot. You go ahead and take that as a snapshot, you snapshot it down, and from that snapshot, you could do things, right? One of the things you could do from that snapshot is create an actual disk that can be mounted on a machine. And so take that snapshot, create it to a disk or convert it to a disk. Converting that snapshot into a disk now gives you the ability to mount that disk on a machine. And if you have the ability, and remember, backup and restore, right? Many people that have backup and restore rights need to test restore. How do you test restore? You might have a machine that you could run. So they may have access to actually create and build machines. So if you have the ability to run a machine, you could then copy that disk or attach that disk to a Linux box, which would be a great example, right? Because Linux would not respect NT file system permissions. It would just read them. And so attach that machine to NTFS and then do whatever you want. And an example would be you mount a domain controller to a disk, take that disk and start to forensicate it. Well, what do you do forensically with a disk? Well, forensically with a disk, you can go in and do some evil things like actually extract all the password hashes from the NT domain structure, right? I'll show you the process for doing this. It's kind of a kludgy-ish process, but again, I just give you a quick example for some of the tooling that you could do in Azure, right? Because if you've seen AWS, Azure's no different. So here's an example of an Azure account. So this is called the Azure Storage Manager. And with the Azure Storage Manager, effectively, you can list out Azure disks, right? So give me an example of listing out Azure disks. So here's a bunch of disks. And you can see that I've got a domain controller and an IIS server. You can literally create a snapshot very quickly by right-clicking on it and say create snapshot. And if you have rights to do this, you know, create a snapshot, very simple. Now, Azure Storage Manager, it's a great tool, allows you to kind of manipulate storage environments. So if you have keys, if you have OAuth credentials, if you have certificates, if you have usernames and passwords, you can actually try to do this, right? And there's all these little tricks that we do to try to figure out whether a username is valid in Azure. Different things that we could do. Let's see. Creating a snapshot. Almost there. Right? So there you go. Created a snapshot. And then from that snapshot, you could do this way. Doing it this way by command line, it's going to take me quite a bit to kind of type it all in. So instead, it's kind of like the Easy Bake Oven. I will show you a couple of things that you could do here in Azure land. Now, there we go. So now let's go to snapshot. And here's my snapshots. And you could always just grab the snapshot, and I believe you could just say convert to disk. Or actually maybe make a disk from the snapshot. I think if we do. Add a new disk. Boom. Resource group. Boom. And source is a snapshot, right? East. Oh. So there's a snapshot we just created. DC1 disk, one new disk, whatever, doesn't really matter. That doesn't really matter. Don't worry about encryption. So we create the disk based on, and actually you don't have to do that. Wow, that's fancy. It creates it as a, you have to do that. It's a very small disk actually. You don't have to break your budget. Anyway, this creates a disk. Once you created a disk, if you have the ability to attach that disk to a drive, I mean, it's not that hard once you've created a disk to just mount it to a VM if you have the ability to mount it to a VM. All this is based on permissions, right? But think about it. How many people do you not know that have backup users? How many of those backup users are using username and password? How many of them are actually doing MFA, right? And so just one-on-one stuff, right? I mean, once you know what you can do on a system, right, then the automation tools for this just leveled up, right? So here you go. I created a disk. I can now go ahead, and you can do this with CLI. I mean, CLI versus GUI, it's not a big deal. But you can go ahead and add a machine, right? If you have enough rights, you can go ahead and add a machine. And if that machine is, say, whatever machine it is, right? You can say, hey, I want to build an Ubuntu box. Fine, whatever. Username, password. I'm just going to say
test 1 2 3 4 5.
webinar user. Yeah.
Not a good password.
It's got to be 12 values, is it? You're going to laugh. Oh!
I think I can guess what the password is.
Yes. But so you can actually just say, hey, I want to do this and I want to touch an existing disk. Right? And, you could create a new disk, attach disks, right? you talk about networking. You can expose this to the internet or not. You give it a public IP address so you can SSH to it, right? You can just say, hey, I want to create a new IP address. Um, right, and just go ahead and create it. Then you can SSH in, mount the drive, right? And that's the whole. What was it that failed? Oh, we had 20. Oh, I can't ask for a new IP address. I had 20. I should be able to do this. There you go. And then once that machine is built and booted, you can now SSH in, mount the drive, read the drive. You got the main controller access, right? And by the way, there's other things you could do, right? This is like one thing you could do with backup restore privileges, right? But if you've got the ability to run commands, so many people don't know this, right? Azure, inside of the Azure VM, there's actually a way to execute PowerShell commands. So you could just run PowerShell, right? There's containers. You could just have a container, right? So there's all these little things that you could do that make this process really interesting from that cloudish perspective, right? It's just a different way of attacking the beast. So let's go in here. Let's take a look. And oh, did I not? Oh, maybe I didn't do this right. Maybe, oh, maybe I locked myself out.
You didn't choose the password, the easy password.
I might have not. You could always add a user. Let's do this. See the run command? There's actually a way to do. Maybe I did this wrong, so hold on. You're probably like, what? You could do this? Yes. This is
Live
what I'm
demos.
talking about, folks. This is exactly what I'm talking about, right? So you could actually do this. As long as you know the magic, you could do this. It takes a minute, by the way. I don't know what the check-in interval is. Oh, look at that. Webinar user. Webinar with 2 R's user. Jeez. Didn't realize I did that. There you go. So you log in, and let's look at the drives here. And so here's the drive SDC. Second one is usually the partition we're after. So let's just mount it. And there's the whole C drive. There's like, everything about it. And this is how you can start forensicating that. And you could see like you can you could go into Windows and you could list out the Windows directory. You can go into like, you could find the NTDS. I don't know if it's, yep. And so this is where Windows stores Active Directory, and you can just extract that, right? So anyway, so high level view of like just backup restore functionality in Windows can give you enough rights to like take over, right? And this is just like a small snapshot of what you can do. So I just want to wrap it up. I know it's a brief, but like, 100-mile-an-hour view of cloud, right? But I just wanted to say a few things, right? Number one, use MFA with programmatic access for humans. Like, if you can, do that. Rotate your keys all the time, right? Rotate them. Do not leave your keys in an unencrypted state. Environment variables, not good. History, not good. Um, try to migrate to instance metadata version 2. Why not, right? Even if you don't think it's great, it's better than version 1, right? And then it doesn't matter serverless, server, Lambda, Azure functions, Google functions. None of that is important if you've got bugs in it. So if I can do, command line execution in serverless, that's not good, right? That doesn't matter the environment. It's just not good. So that's critical. That's a critical thing. So software bugs will still be important regardless of the platform you're running, whether it's a PaaS or whatever. Also, things that we didn't talk about, but that are still critical when you're doing pen tests. Open anonymous shares, expose APIs, like Docker. I looked the other day, there's thousands of Docker APIs exposed on the internet. No, that's bad, right? Container APIs exposed. No. Versioned APIs. Like, if you've got a versioned API, this could be bad, right? Just something to think about, right? Like if version 1 had a software bug, but it's still available, that's not good. Containers can be backdoored. We've seen these, right? Pivots through IAM keys, what we did today. Pivots through containers, that's totally inbound. And of course, the one that people still seem to not understand is that you have network routes, right? Typically from your data center back to your, to your cloud environment. This is another entry point in and out of your data center that you have to think about, right? So we cover all these topics in the SANS course, but we want to kind of give you some ideas for how that actually differentiates itself from your typical pen test. These are all critically important functions that we're seeing out there on the internet. So I think that's what I've got. This is how you can find me, but I'll leave it open for a few minutes here for any Q&As that I may have missed that that anybody that wants to ask can ask.
Anyone? Otherwise, I'm going to start asking stupid questions, such as, what's your favorite movie, Moses?
Ooh. Oh, man, that's really hard. I'll give you some really pretty ones. I think, let's see, which ones were pretty good. I saw Interstellar again the other day. Interstellar holds up really well. That one holds up
Yes.
really well. Let's see. Good movies, huh? You know what? You know what's surprisingly good for horror movies are those Bloomhouse ones with that old lady. What was it?
Oh, I can't do that. Not me.
Those held up pretty well. Uh, um, let's see, which one else is pretty good? Uh, you know, you gotta hand it to the Marvel folks. They did a great job. But the first Christopher Nolan Superman was pretty good.
Yeah. Yeah.
You'd have to say that. They got people doing Westworld now. I can't get into the second Westworld season. When did I get the
It's a
long
lot.
hair? I started growing my hair out. So my wife was like, "Hey, you better grow your hair out." So about a year and a half ago, it's the first time I've had it this long in my life, and I'm completely not used to it. So I don't know how to sleep with it. I don't know how to eat with it. I don't know how to put in a ponytail. I don't know how to do anything with it. Right? I feel like a 4-year-old. So.
All right, let's advance slide. Let me just talk about how people can find this recording, and let's talk about next events as well.
Oh, I think I have one question.
Yep. Go ahead.
So Anti-pattern. So, um, do you remember at the beginning of the or during the demo we had environment variables with API keys? That's an anti-pattern. Like that is not what you should do, right? That is a bad practice, right? So unfortunately, as we've kind of stepped through things, right? We've learned what are good patterns and what are anti-patterns, and that's an anti-pattern, unfortunately. So we need to be able to secure these keys in a way that's better than that. Kubernetes has their secrets where you can basically mount the drive and read the secret. But the problem with this stuff, right? The problem with these things, right, is that at some point you do have to read keys, right? And so whether I am running Mimikatz and I'm reading sections of memory, at some point you got to figure out how to read and write the keys. I mean, I know people say HSM and you could use an HSM, but if I have rights to call the HSM and ask the HSM to give me the keys, effectively that doesn't help either. So it is a big problem and it's not something that's easily addressed.
Cool. Thank you, Mary. All right. All right. I know audience is shrinking, so let's talk about next event. Folks, if you would like to see how to examine cloud file storage incidents, that's our next event coming up. And then we will also talk about IoTs focused on healthcare. So if you would like to join these events, we will show you the barcode in next slides. And here we go. If you scan this barcode, we will have all the event information on our Twitter, LinkedIn, and this recording will be posted on YouTube, and slide deck will be posted on our Git and LinkedIn as well. All right.
And that's it.
And that's it. Thank you very much for everyone to join in. I know it's Saturday. Thank you, Moses. I know everybody has joined it. Thank you so much for this.
Yep, you got it.